Have you ever wondered what happens behind the ChatGPT interface? We tell it a text, and besides we know that computer can only understand in zeros and ones, it not only comprehends but replies in a way similar to humans. Today, we will try to understand the basics behind ChatGPT and the first step towards building your own LLM, that is tokenization. So, keeping the big words aside, let's dive into it. We will start by understanding with a prompt to ChatGPT, that is, do you know any affordable Italian sports near me? Now, behind the scenes, it converts this text into token as highlighted, and then these tokens are converted into token IDs. This process is called encoding. As part of Tokenizer, let me take you to the diagram which makes our life more easy. Here, as you can see, we are passing the same sentence to an encoder which generates array of IDs, which is nothing but some vocabulary which is having its own assigned unique integer ID. Now, we can think of vocabulary as a dictionary where each word in a dictionary is assigned a unique ID. Once the word is encoded, it would be prepared for further process called embeddings, positional encoding, transformational layers, feeding forward linear layers, softmax, and so on. However, for this part of the building LLM from scratch, we will be only focusing on tokenizer. Now this will include tokenizer, token IDs, and then decoding those IDs into the text. Now we will talk about the last step of the tokenizer, which is called decoder. Now, similar to what we saw in encoder, when a string was converted into integer values, here the decoder job is to convert integer back into the string. This sums up the working purpose of tokenizer. Now let's dive into the code. So I've downloaded an open source book that's freely available on the internet. It's called The Verdict. You can use any book of your choice. So the first thing is that we will read this book. So I've already read that book once. Now we can see that the total number of characters in this book is 20,479. So over here I've just printed the top 99. So before we dive directly into building tokenizer, we know that tokenizer contains of two steps, encoding and decoding. The first step is encoding, where we are just passing through a sentence into some token IDs. So that would mean encoder would require that sentence in specific format, or at least it should be able to distinguish between those words or the tokens that we are passing through. So for that purpose, I'm just explaining through some common functions that is readily available in Python. So for that purpose, I'm just using regular expression library, and you can utilize the same or any other similar libraries available online. So here I've just taken a sample text called hello learner, how are you? Now this text, I'm splitting it based on the spaces. So once I've split it based on the spaces, we can see that it's split it into multiple characters separated by the spaces. However, we can notice that the comma as well as full stop as well as question mark, these are still included inside our words, and we don't want to do that. So here I'm making sure that my split function is also removing these separators. Now once I've splitted them, we can see that there's a long list of tokens that has been divided into an array. Now what we don't really want is those spaces between, because that's or spaces or just this empty value, because that's the redundant data for our encoder. So here I'm just removing that. So once I've removed that, I'm just stripping through all the different characters that can come through in my raw text. So now that was the first part. So once you have understood this part, what we are going to do is we are going to apply the same thing that we did on that text to our raw text of the book. So that's what we have done. So after pre-processing, these are the only number of tokens that are present in that book. So we can print here I have printed the top 30 characters of that book. So once we have done that, we have to convert the tokens into token IDs. So how can we do that? So these are the another functions or set of library functions that are pre-built in Python, and it makes our life so much easier. So ensure that there is no duplicate in it by using set, and then we are sorting it based on the ascending order of the values, and then we are putting it inside the all words variable. Now we can see that the size of this all words variable is 163, and here I've just printed through the top 20 characters of that. Now just to create our vocabulary, which is basically a key value pair or a token as well as integer pair of the dictionary that we want to create. So I'm enumerating through all the words and then creating an dictionary which represent the first word will represent a token, and the second word will represent the integer which is corresponding to that token. Now I've done that, and we can see that all words are of type list. Now we will start creating a simple tokenizer, that is encode string to id and decode integer id back to string. So here I have created a simple tokenizer version 1. I'll just pass all the string to integer values as a similar to vocab, and integer to string values as index, which is nothing but the token id, and then the string value will be representing the string that is corresponding to that vocab, to that index. Now I've created another dictionary out of it just for initialization. Now once we have that, there is the encoding function where we need to encode the string values into the integer id. So as a part of string, we are passing through the text value, and then we are applying the same pre-processing that we did before, that is to split the text value that we received into tokens, and then those tokens ensure that they don't contain any spaces ahead or before, so those are stripped, and then we are just assigning IDs to those tokens based on the vocabulary that we have. Now I don't know if you guys have noticed, but there can be some of the vocabulary which might not be present inside the vocabulary that we have created, or there could be words outside the vocabulary that we have created. That combination of words or that permutation of words is not being handled by encoder. So let's see how it will behave in future. But before that, let's understand the decoder function as well. So the purpose of decoder is to convert all the IDs into string, and that's what it is doing. So it's joining all the IDs again back into an array of dictionary, and then once it has done that, it will be again reading through the text value that is corresponding to that IDs and then converting inside into a text, and that's what it returns. Now we can see that this hello value wasn't, I know that it was not included inside the vocabulary that we have created. So I've just passed through hello here and then added a sentence called hello, how are you? So here I've just initiated a simple tokenization version 1 with the vocabulary that we have, and then using the encode function. Now as you know, hello was not part of the vocabulary, hence it starts giving us the errors. Now we know that hello was not present. So what GPT-3 builders did was they solved these kind of problems by using these two kind of tokens. So there can be an end of text which separates two different paragraphs or two different entirely different contextual concepts, or there could be an unknown that is received in the input that a user has added. So they created these two tokens and appended that to the list of vocabulary that we have. So that's what I did. Here I'm just extending our vocabulary to these two characters, and once we have done that, recreating my vocabulary, and just to see how it's getting assigned, we can see that here the end of text is having 1163 value and unknown is having 1164. Now I've just enhanced our simple tokenizer to version 2. Here the simplest thing that I have done is to ensure if anything is not available inside a vocabulary, then what you need to do is assign unknown keyword to that item, that is present in a pre-processed or the text that the user has sent. And that's the only change over here. The rest of the things remain same. Now if I'm passing through the same sentence to the version 2 of a simple tokenizer, we can see that it's encoding as expected. Now the hello has been assigned one unknown value. So let's see what happens when we decode it. So when we decode it, we get the unknown back. So yeah, that's it for the tokenizer. Let me know if you liked the video, and stay tuned for the rest of the parts of building LLM from scratch.